All right, this lesson is called Solving for Angles That Are Non-Standard, meaning these are angles that aren't a special right triangle on the unit circle. They're still on the unit circle, it's just at values that aren't standard. They're not our normal root 2 over 2, root 3 over 2, 1/2. And so we're going to start with this example of cosine theta equals negative 0.5. Well, first we need to remember that cosine are the x values. And if I remember that this point over here is negative 1, 0, or 1, 0, and this is negative 1, 0, I could say that 0.8, negative 0.8, let's say it's about there. And I'm going to draw that vertical line. And so I could see that on this unit circle, that cosine of theta equals negative 0.8 twice, which makes sense because it's negative in quadrants 2 and 3, and between 0 and 2 pi, which is what we're actually solving for here, 0 and 2 pi, we usually have two possibilities. So if I draw out my terminal side here, what we are solving for is this angle. And that means still, whatever angle is in here, that is a reference angle. And if I drew my second terminal side over to here, we also want to find that angle. Let's call this one theta 1 and this one theta 2. In here is that same reference angle. So kind of a convoluted picture, but I want you to see what's written in pink down here. Both those angles, theta 1 plus theta 2, are going to add to be 2 pi. And I just want to show you a quick proof on that. So here, if I'm looking at theta 1, we could say that theta 1 is pi minus theta r, right? Like it's not quite 180 degrees, it's short, the reference angle. And then we could say theta 2 is pi plus my reference angle. So we went all the way over here to 180 and then we added our reference angle. Now what happens if we add theta 1 plus theta 2? I get pi minus theta r plus pi plus theta r. Well, those two cancel out, so theta 1 plus theta 2 must equal 2 pi, all right? So anything reflected over the x-axis, those two angles that give me both the same value of negative 0.8 or whatever the value is, those two angles are going to add to be 2 pi. So first, we want to solve for what is theta. And we do that by taking arc, cosine, or inverse. So what we have is theta equals cosine to the negative 1 of negative 0.8. So really important on your calculator, you want to make sure that you are, if you go to your mode, that right here you are in radians, not degrees. So I know those of you who have been working on law of sines, we've been in degrees. For this, we need radians. So mine is already set. So I'm going to clear everything here. And then I want to find my angle. So I'm going to use inverse cosine right above the cosine. Sorry, there's a glare on that. So let me pull it a little closer. Negative 0.8. And I see that that means that I get this number 2.498. So theta 1 equals 2.498. Whenever you do the inverse using your calculator, you're always going to get just theta 1. It's only going to give you one angle. And this is radians. Now, we still want to get theta 2. The calculator's never going to give us that. So that's where we use what goes on in pink over here. We know that 2.498 plus theta 2 has to equal 2 pi. So then subtracting 2.498 from both sides, I get theta 2 equals, and you're just going to use 2, and if you have a pi button, use that, or multiply it times 3.14 minus 2.498. And our second angle, theta 2, is going to equal 3.785. All right. I want you guys at this point, let me try to get this all in. I want you guys to finish taking notes and then pause and try to do this cosine theta of 0.65. And when you get back, we will go through it. We'll add some rules and then we'll do tangent. So I think I'm going to end up doing one longer video. It's just going to take longer for me to process. All right, so 0.65, let's just say if this is 0.5, it's about right here. You don't need to be too accurate, but we know that this point up here is 0.65 and some y, I don't even care. And we want to find theta 1. So we're going to take the inverse cosine of 0.65. So when we do that on the calculator, I get that theta 1 equals 0.863. I'm going to have you round out for the most part out to your third decimal. And now in order to find theta 2 is going to come all the way around to this angle. So we're going to have 0.863 plus theta 2 equals 2 pi. And solving for theta 2, I get that theta 2 equals 5.420. Right. So hopefully that made some sense. You will need a calculator, so make sure you have an option. Make sure it's in radians. All right. I do want to go, and I want to just take a moment for you guys to put these in your notes. We're going to talk about sine on Thursday, Friday. But these are the rules. These are the rules for non-standard angles. Right. So hopefully you've gotten that down. We're going to spend a little time with tangent now. And tangent is probably your easiest one of all these rules. One thing we remember about tangent, and again, we're not doing all angles, 0 to 2 pi, is that the period for tangent is pi. And in the past, when we have solved for all angles, for tangent, we've had some angle, theta, and then we've added pi k to it. And that has given us all the angles. And so for that reason, that's all I need to do here. If you notice what's written in pink down here is because tangent just rotates 180 degrees because of its ratio of y over x, then it's just whatever your first angle is, theta 1, which you'll get from your calculator, plus pi to get your second one. So it's a little bit harder to figure out where these are in the unit circle. But if we remember from when we went over inverses, that tangent inverses are only in quadrants 1 and 4, we can assume that tangent of negative root 3 is out here, and whatever the x and the y here, that y over x gives you a negative root 3. And we've actually, this is something we've already done. But notice because it is negative, we know that one of my values here has to be positive and one has to be negative. And in this case, the x is positive and the y is negative. We're using our calculator on this, and so I want you to not worry about the special right triangle, although I believe this is where x equals 1/2 and y is negative root 3 over 2. So we can use that to check ourselves. Then that means that this should be pi over 3 here as a reference angle. And so if we're solving, we're probably going to get 5 pi over 3 for that. All right. The other place where I would have the negative root 3 is 180 degrees past it, where I have the same x, but now it's negative, and the same y, and that's going to give me that negative root 3. So again, using our calculator, what we want to do is tangent or inverse tangent of negative root 3, and that is going to give us theta 1. So in that case, turning the calculator on, I'm going to use inverse tangent, negative root 3. Oops, I don't want that to be there. So come out here, put my close parentheses, and I get negative 1.047. Is that negative pi over 3? Let's just check. So we have second pi divided by 3. Yep, if we added a negative, that is negative pi over 3. And then if we wanted the next angle, well, one thing I want to talk about is this number between 0 and 2 pi? Nope. I need to find something coterminal with it. So I'm going to add 2 pi to it, which is going to give me my 5 pi over 3. So we're going to take that negative 1.047 and add 2 pi to it. And that gives me 5.236. That's just coterminal, and I believe that's probably 5 pi over 3. So 5 pi divided by 3. Yep, same thing. Okay, now this is theta 1. And we want to actually find this angle over here. So taking my original number there, we're going to take theta 1, which is my negative, and we're going to add pi to it, and that's going to bring us to this angle. Why am I using the negative twice and adding 2 pi once? 1, because I want to put this within my domain, and 2 is I'm not going to add pi to this number because that's going to be outside of my 2 pi domain. So I'm going to add it to the original. So if I come up here, negative 1.047, and I add pi to it, I get 2.094, which should be at 2 pi over 3. So we can just check 2 pi divided by 3. Right. I want you guys to try tangent of theta equals 1.5. So I'm gonna, if you guys can pause, you can finish your notes and then pause. And then I'll come back and do it with you. Okay, so hopefully you had a chance to work that out. Tangent is positive in quadrants 1 and 3, so I'm just drawing the picture. You don't have to draw the picture, but some positive x and y over here, and down here it's going to be that same x and y, but they're negative x and negative y, and the division of those, y over x, is going to equal that 1.5. So again, we just want to start with finding theta 1, which is inverse tangent of 1.5. So if we do that, I take inverse tangent 1.5, and I hit enter, and I get, for theta 1, it's 0.983 when I round it. I'm going to check, is that between 0 and 2 pi? Yes, it is. So I don't need to find a coterminal angle. And now to get theta 2 for that one, I am going to take that 0.983 and add pi to it. So when I do that, I'm going to go up here, click my answer, add pi to it. I get 4.124. And that is also within 0 to 2 pi. Knowing that 2 pi, 2 times 3.14 is approximately 6.28. All right, that's the end of this video. Make sure you watch it and ask questions. Come to office hours if you need.